Welcome. Thank you for joining us for After Dark Online, Contemplating Creativity. My name is Kathleen McGuire, and I'm part of the team that produces these After Dark programs. While tonight's program has been recorded remotely, we would like to acknowledge that the home of the Exploratorium, Pier 15 in San Francisco, is on unceded territory traditionally belonging to the Ramaytush Ohlone people. We recognize we are guests on this land, and we pay our respects to elders both past and present for their stewardship of this land. Throughout November, our After Dark programs have lightly focused on sustenance, exploring the qualities, practices, and materials that can connect us as a culture and provide fundamental nourishment. In tonight's program, we're focusing on creativity, and nestled beneath that very broad concept is the role that observation can have in understanding the world around us and prompting creative exploration. You'll be hearing from Fiona Gologli, whose nature journaling practice is rooted in creative observation. We're also very excited to share a conversation between Psyche Loui and the Exploratorium's Wayne Grimm. A classically trained musician, as well as a psychology and neuroscience researcher, Psyche will be discussing her insights into musical creativity through a neuroscience perspective. Tonight's program will conclude with the latest edition of Resonance, our series on music and sound created or captured in unusual or interesting ways. Tonight's featured artist is Adria Ate. First up, though, we'll be kicking things off and getting your creativity sparked. My colleague, Steph Muscat, who's an educator with the museum's Tinkering Studio, will host 3 segments that are sprinkled throughout tonight's program. Steph will be inviting you to explore balance with her and exposing the creative potential of ordinary materials found throughout your home. She'll showcase many creative balancing sculptures created by her Tinkering Studio colleagues, as well as public participants who contribute to those explorations through the Twitter hashtag #ExploringBalance. Hopefully soon we'll see that hashtag populated by your balance sculptures. And as you might be wondering why I have all these things in front of me, these are my materials that I hope will result in a balancing sculpture tonight. So here's Steph to tell us how to get started.
Hi, I'm Steph from the Tinkering Studio team at the Exploratorium. And tonight, we're going to be playfully exploring balance and stability. We'll design whimsical, kinetic sculptures by tilting, sliding, and suspending everyday objects and ordinary materials into surprising arrangements.
When we say balancing sculptures, we're talking about precariously positioned constructions that use ordinary materials in surprising and artistic arrangements. Often perched on a point, these balancing builds invite a lot of making small adjustments, trying different iterations, and looking around your space and the objects in it with fresh eyes.
Before beginning to build balancing sculptures, a good place to start is to collect a set of materials to explore. And one of the qualities that we love about this activity is that there is no one correct set of materials. The world is full of stuff that was invented to do one specific job. But tonight we'll be taking some familiar objects and using them in unfamiliar ways to see what happens. So you'll see. We'll introduce some ideas for starting points right now. We'll share some of the qualities and the characteristics that we look for in those materials. And then we encourage you to look around your space and just try things out. So, here are some ideas for materials to start with. Collect some things that can be used as a perch for your balancing sculpture. The first perch that I actually like to test out is just my finger. So you can see Here's a balancing sculpture I've been playing with. There's just a pencil with some wire, washers for weight, and then binder clips at the end. And I can test it out on my finger to see how it balances. You might think about other objects that could be used as perches, maybe chopsticks or writing implements. I actually really like pencils because that eraser on the end isn't slippery. So you can get some interesting balance action there. Whew. You'll also want to gather some materials that vary in weight. So here I have some washers, nuts, and other hardware of various sizes. You might also think about craft materials like light paper or feathers that you might have around. And you'll notice too, I tried to gather a lot, many multiples of the different objects to explore. We like to set out an abundance of materials so that the world feels editable and nothing feels precious. Kitchen utensils and other objects that aren't completely symmetrical can also behave in unexpected and intriguing ways, so they're worth testing out. But really, it's when you start combining different materials to see what happens that things start getting a little more interesting. So collect some materials that you can use as connectors. Materials like wire, even things like cork or pieces of potato or apples where you can kind of stick things into the side can be interesting connectors. We'll be talking more about making your own cardboard connectors or using buttons as connector pieces. Materials like binder clips can come in handy too. Tape can be helpful too, especially if you want to create a stable base for your balancing sculpture. So here, for example, I've taped my pencil perch to a mason jar, and it means that I can test out my sculpture, see how it balances, and make adjustments on a freestanding base. And remember, things will fall over along the way, so please document as you go. We would love to see what you're testing out, especially when it falls over and everything comes crashing to the ground. So you can use the hashtag #exploringbalance to share what you're making and also to see what other people on social media have been testing out. This is a good time to go collect a material set and start tinkering. Gather some unexpected objects of different weights, try out different perches, and we'll be back soon to talk more about connector pieces, bases, and to just show off some of the cool things people are trying.
What a fantastic start to exploring balance. I enjoyed creating along with you. I did have some mishaps, but right now it looks like these balance sculptures are going strong, and I look forward to seeing more balance sculptures and hearing more ideas about how to approach them from Steph and her tinkering colleagues throughout the program. Up next, we'll be hearing from Fiona Galogli about her nature journaling practice. Fiona, age 17, has loved art and nature since she was a little girl. In 2016, when she discovered nature journaling and the work of John Muir Laws, she was thrilled to find something that combined these two things she adored. Now a passionate nature journaler and naturalist, Fiona has created more than 2,000 journal pages since she began this journey. She loves to craft, she loves to act, she loves singing, harmonizing, playing cello, composing music, writing stories, and speaking German. An avid birder since 2015, Fiona is a 5-time recipient of the Central Valley Birding Club Youth Scholarship. Since 2018, Fiona has volunteered on a bird banding and monitoring program, gaining valuable hands-on experience in ornithology. Her mentor, John Muir Laws, has said of her, "Fiona is the most curious person I've met in all my adventures, and she's helped me up my personal level of curiosity with the world." So here we'll hear from Fiona.
Thank you so much for letting me be here. I'm super excited to be part of this evening's presentation. So I am here to talk about one of my favorite creative things to do, which is nature journaling. So nature journaling is basically taking your art kit out into nature and drawing whatever you see. So I started doing this when I met John Muir Laws, who has become an amazing friend and mentor of mine. And he introduced me to this idea of nature journaling. And he showed me what a powerful practice it can be. So it really helps you remember. So when you've been drawing and asking questions and writing observations about something, you can go back to that day, go right back to that day and remember what you were doing. And it's so much fun to have this place to go back and remember, oh yeah, I was there at the river and there was this bird and it was so beautiful. So that's a really powerful way that it helps with your memory. It also helps you get your brain on paper. So when you're looking at something in nature and you have a question or you have an observation, if you keep those all in your head, it can get really overwhelming and you can't really, it kind of becomes a mess. But if you write down those observations and questions, you can connect them and you can see trends and you can start to understand better what you're thinking about and understand more what you're looking at as well. So it also helps you think about what you're thinking about. So once you've asked all these questions and written them down, you can take a step back and be like, wow, I wonder why my brain went there. I wonder why it reminds me of this, or things like that. And it also helps you pay more attention. When you're drawing something, you have to look again and again and again, and you come up with cool observations and cool questions, and you stay with it longer. And the more attention you pay to something, the more you fall in love with it. You get to see how beautiful this bird is or how gorgeous this tree is, and you get to really fall in love with the natural world. So here are some examples of my nature journal pages. So this is not the only way to nature journal. There are many ways to nature journal. This is just how I do it. So I write a lot of questions. I draw. I'll put the date and the weather in the corner and where I am. So I was in the Sacramento Valley and I was drawing sandhill cranes and tundra swans, which was really, really fun. Here's another example of what I do. This was a dead fish by a river near my house that looked like it had a claw mark from an eagle or an osprey or something in it. So I was really interested as how it got there and why did whatever had it drop it, like what happened. So that was kind of the main questions on this page. I measured it. I was looking at the scales. Anyway, so that was a really fun little page. Here's something else I love to do. I'll put in little comics if the story is really fun, of how I found this. So on this page, the spider, I have chickens at my house. So I was going to close their coop and I happened to see this spider hanging from the trees nearby. And I was like, that is so cool. So I went and I got a jar and I put the spider in the jar and I drew the spider. I stayed up really late drawing the spider. So that was kind of a cool story of how I found it. So I made a little comic on the top up there. So I often do that too. And I did that with the leopard lily as well. So this was a day at the beach. There were some snowy plovers and Caspian terns begging for food. This was near Point Reyes. And there was also a peregrine falcon, which was sitting up on the cliffs, and it flew out and it caught what I'm pretty sure is a blackbird, but I'm not sure. And it came back and it was shredding the blackbird and the feathers were flying everywhere. It was crazy. So that's kind of another example of what I do. So one of my favorite things about nature journaling is curiosity. As you can see, I have questions all over my page. And so I don't worry about the answers right now. I do ask questions of other people and get answers, and I look things up. I do look for the answers sometimes, but I found that asking questions takes me to places that I wouldn't have gotten to otherwise, just by asking the questions and not worrying about the answers. If I felt the need to answer all the questions I ask, I wouldn't ask as many questions. I'd feel scared. I'd feel self-conscious that I can't answer all the questions I ask. So just asking them freely is so much fun, and it takes my brain to new places that I wouldn't have gotten to otherwise. So the answers are important. Completely, the answers are important, and it's not an either or, it is a yes and. So I ask open-ended questions, not needing the answers right now, and I also look at the answers. I do both. Also, neurologically, it's really cool. When you're getting curious about something, you get dopamine. So you go into a flow state. Runners talk about this, like a flow state where it's like it's your happy place. And it cuts blood flow to the place in your brain where your self-critic lives. which is really nice because then you don't have the little voice on your shoulder telling you that, that you're bad at things. So that's part of why I nature journal. It's really, really fun. And I love falling in love with what I'm looking at. It's one of my favorite things to do in nature, but it also silences my self-critic, which is really, really nice. So here is some examples of playing with curiosity in nature journal. So this was some dodderweed, which I'm pretty sure this is how it works, but it's a little parasitic vine, and it wraps around pickleweed, which is something that's in a salt marsh, and it basically takes nutrients from that pickleweed. So I was asking questions about this. It's non-photosynthetic. I find that really cool. And it was really nice because I got to stay with this dodderweed for a long time. And it was because I was curious about it that I stayed with it. It's kind of this, it's just this little weed on the ground, but because I was so interested in it and I sat down, I stayed for almost an hour drawing this little thing and asking questions about it and wondering why it was like that. So I expanded one of my question chains to kind of show you like where my brain goes on a typical question chain. So I start over here in the upper left with just an observation like, wow, it's such a bright orange. It's such a beautiful color. And so I was wondering why that was. And you can kind of see my little chain of where my brain went. So because it doesn't need to photosynthesize, I was wondering, so how much nutrients does it take from the pickleweed? And I was wondering if it's enough to kill it. But the pickleweed didn't look dead, so I was wondering if the dodderweed was just a nuisance. But then I noticed that the pickleweed was making a mat over the dodderweed was making a mat over the pickleweed. And I was wondering, does this affect the pickleweed's exposure to sunlight? And if so, by how much? And does it decrease the rate at which the pickleweed can photosynthesize? But then I was wondering, wouldn't it be in the dodderweed's best interest to keep the pickleweed photosynthesizing since it's feeding off the nutrients? And so then I decided I was going to look under this mat of dodderweed. So I did, and there was a lot of dead pickleweed under that mat. So I was wondering, does this mat of dodderweed kill the pickleweed? Is it from the loss of nutrients that the pickleweed dies, or is it from the lack of sunlight, or both? So that's kind of where my brain went with one of these question chains. So I kind of expanded it to kind of make it a little simpler. But that's on this page in the lower right corner is because I do my journal just for me. I don't need to show it to anyone. I don't make it to be shown. So I just thought I would expand it just to kind of show you what my brain does. So this is another fun story about curiosity. I was also in the Point Reyes area driving down a road, and my mom was like, oh, there's a bird on the telephone wire. And I was like, oh, cool. So I leaned out the window and I was like, Mom, that's a great horned owl. So we pulled over, and there was this beautiful great horned owl sitting right on the telephone wire, so close. So we were like sitting just outside of the car, and I was drawing it and asking questions about it. And we stayed with it for probably 10 minutes. And it was watching the ground, and it was kind of getting cold. It was dusk. And then it started doing this weird, like, yawning thing. And I was like, why is it yawning? Like, that doesn't make any sense. And then it coughed up 2 pellets. And so me being the crazy, nerdy naturalist that I am, I watched where those pellets fell. And I had a plastic bag in the trunk of the car. So I took this plastic bag and I went over to where I had seen the pellets fall, and I put one of the pellets in the bag, and I took it home and I let it dry, and then I dissected it and did a little inventory of all the bones that were in the pellet on the other side of the page. So if I hadn't stayed with this bird, if I hadn't been curious about it, and I hadn't been excited to keep watching it, I wouldn't have seen it cough up this pellet, and I wouldn't have been able to go down that whole avenue. And also I did a little comic of how I found this bird too, which was kind of fun. So this is also another kind of curiosity thing, and taking answers and turning them into more questions. So I had been drawing from Steady Skins a while ago, and it was a pigeon guillemot, and it had yellow feet. And I asked one of the people I was with, I was like, why are its feet yellow? Because guillemots in the wild have red feet. And they said, oh, when they die, their feet fade. They lose that red color. And I was like, that's so weird. Why is that? So on this pigeon guillemot that I found on the beach many months later, I noticed that its feet were kind of a dull orange color. And I was wondering, is there any sort of correlation between, can you tell how long the bird has been dead by the color of its feet? So that was kind of the main question on this page, was looking at the color of this guillemot's feet and wondering how long it had died, how long ago it had died. So this is a really fun story. So this is a little California scrub jay that I saw at my feeder. I was eating lunch and I happened to look up and there was a scrub jay on the feeder eating some suet. And it had this huge white patch on its wing. And my brain totally started freaking out. It didn't match anything I'd ever seen before. And I sort of eventually came to the realization that it's a partially leucistic scrub jay, which was crazy. I had never seen a leucistic bird before, so I got super excited and I got out my nature journal and I started drawing this bird. And then it occurred to me that blue is a structural color, which was something I had learned before, which if you take like a feather from a blue bird and you hold it up to the sun, with the sunlight coming through it, it looks black. And it's because of the way the feather is structured and it refracts blue light. It's super, super cool. And so I was wondering, did the leucism change the structure of the feather to cause it not to have that blue color anymore? Like, how does that work? I thought it only affected pigment. So I still don't know the answer to this question. I didn't even know that leucism could affect structure, or if it even is leucism, I don't know. Or if it's some other disease that alters the structure of the feather, I'm not sure. But it's been really cool. I've gotten to see this leucistic jay come back to my feeder for many weeks. It's still been coming back to my feeder a couple times a week. It's been really cool to watch this bird grow up. And it was a baby when I first saw it, or it was young. It had gray on its head. And so it's been really cool to watch it grow in its adult feathers and come to the feeder. So that was a really, really fun little story. So we don't really ask questions in our society. Our society doesn't really value questions. We kind of see people who ask questions as stupid because they don't know the answer. And that's not the case at all. And curiosity is super, super important. And young people, children ask a lot of questions. If you've ever been around a young child, they're constantly asking questions. Why is that? What about this? They're constantly asking questions, but at some point they stop. And as I was doing research for this talk, I came across this article in Newsweek. It's by Poe Bronson and Ashley Merriman. It's about 10 years old, and it's called The Creativity Crisis. And it's basically talking about how children over the course of the years have gotten less creative. And why is that? And one paragraph that really, really stuck with me, a quote that really, really stuck with me was, quote, preschool children on average ask their parents about 100 questions a day. Why? Sometimes parents just wish it would stop. Tragically, it does stop. By middle school, they've pretty much stopped asking questions. It's no coincidence that this is the same time when student motivation and engagement plummet. They didn't stop asking questions because they lost interest. It's the other way around. They lost interest because they stopped asking questions, end quote. That paragraph was just so amazing to see that it's not because they lost interest and so they stopped asking questions. It's that they stopped asking questions and so they lost interest. That they've been in this society where we frown upon questions. And so I found that asking questions in my nature journal has given me the tools to feel more comfortable asking questions in school and asking questions in life. And it's helped me feel more comfortable being curious and not feeling stupid. And this is something we can all do. We can all build our curiosity. We can all try this. We can all ask questions. And it's really sad that our society frowns on questions so much. And it's not only that asking questions are fun. Creativity and curiosity are really, really useful in problem solving. And we have a lot of problems in our world right now. And we need creative and we need curious people to help find creative and cool solutions to solve these problems. And you can do this too. My mentor, John Muir Laws, has a website, johnmuirlaws.com, and he has all sorts of free video tutorials on how to start nature journaling. There is no wrong way to do this. You can just go out in nature and draw what you see and ask questions and have fun. And the more interested you are in something, the more interesting it is. That's something I like to say. The more interested you are, the more interesting it is. The more you're interested in something, the more you're going to stay with it, and the more interested you are going to get in it. So thank you so much for having me here tonight, and I really hope you enjoyed it. Thank you.
We're back for some more balancing sculpture action. My teammate Deanna has been making these really delightful balancing sculptures using wire and washers. She also built documentation and reflection into her creative process. She's keeping track of what she tried in a really beautiful and inspiring way. Deanna, I'll hand it to you to show off some of the creative perches and bases that you've discovered and invented to showcase your pieces.
Hey After Dark, my name is Deanna and I work in the tinkering studio. I've been exploring bases here at home, and I'm going to share with you a few tips and tricks from things I've discovered from playing around with different types of bases. So when I first started messing around with balance, I immediately went to my fridge to see what types of food I could use to balance my sculptures on. So here's an example of one of my sculptures. It's one of my favorite ones. And I found this lemon. And I was really surprised when this sculpture balanced so well on the lemon. But I think that's something really magical about playing around with balance, is to explore different base types. And maybe you too will be surprised by what works really well for your balancing sculpture. One type of base that I've been playing around with just uses a jar filled with rice and a candlestick. Now you can imagine that this jar could be filled with something else like sand, and this candlestick could be a lot of different things. But what's unique about it is I can place the candlestick inside the rice, and the rice helps keep it upright pretty well, which then works to help balance one of my sculptures. When you're building out your bases, to think about, do I want my base to evoke any feelings in my viewer? Here, I was starting to think about, could I maybe play around with adding some drama or some suspense to my balancing sculpture? Here I've got a ruler that is taped to a box here on my table, and it's adding more height to my balancing sculpture, which could add a little bit more suspense. Is it going to fall over? Will it stay upright? And that is something that's really fun to play around with when you're looking at balance. So all of the different balancing sculptures I've shared so far have one thing in common. They all balance really well on a vertical point. And while this is really unique and is a really fun way to play around with kinetic sculptures, it's not the only way that you can play around with sculptures like this. So you can also imagine that perhaps you could have a horizontal point that your balancing sculpture rests on. And some of these balancing sculptures lend themselves really well for that style of support. So for example, this works really well for a horizontal point, maybe not so much for a vertical point. So if you're deciding to build different balancing sculptures that are in this style, you might need different types of bases to balance your sculptures on. So here I have a wine glass, and you can take then your balancing sculpture and rest it right on the rim. So also just don't be afraid to try to remix or reimagine everyday objects you have in your house, because they might work really well as a base.
Consider unexpected objects like a watering can. Or go outside and collect branches to test out as bases. You can even transform your furniture into a base by taping pencils or other tall objects onto it to make your own sculpture. Experiment with recyclables, like soda cans. Really, it's about looking around and getting creative with whatever you happen to have on hand.
Hello, I'm Wayne Grimm. In a moment, we'll be speaking with Psyche Loui. Psyche Loui is a psychology and neuroscience researcher, a musician, Assistant Professor of Creativity and Creative Practice at Northeastern University, and Director of Music, Imaging, and Neurodynamics Laboratory. Research in Psyche's lab aims to understand the networks of brain structure and function that enable musical processes, auditory and multisensory perception, learning and memory of sound structure, sound production, and human aesthetic and emotional response to sensory stimuli. Tools for this research are motivated by the following questions. How do humans perceive music? How do expectations develop? How do structural and functional connectivity in the brain enable perception and action? And finally, how can music be used to understand the brain and to help people with neurological and psychiatric disorders? Hello, Psyche. Welcome. Thank you for being here.
Thank you for having me. Hello, Wayne.
It's great. I'm really excited to talk to you about music and the brain. And I guess I'd like to start off with a really basic question that might be really difficult to define, and just say, what is music?
Well, I always like to start with the big questions. Well, I think if you buy the Ferez definition of music as organized sound, I think that already gets you quite a long way towards the diverse experiences that are music today. But I think that we also know that music isn't only about sound. I mean, I think it is quite a multisensory experience. It's a motor experience. It could be a vocal experience. So sound is part of it, but I think it is so much about the intention as well. So I think that organized is another part where you think about what exactly that means, right? It could be about having a structure, right? Or it could be about having an intention. And I really like the musicologist and music theorist Fred Laerdal's definition of music, or actually of effective and successful music, is about the alignment of a composer and the intentions of the audience, right? So it's about different minds aligning with each other. So I think that, much of my life is thinking about how that happens and why that happens. So I guess if I were to define music, I would say it's a shared experience, and it could have certain structures associated with it. It could have certain stimuli, such as sound stimuli or visual stimuli, associated with it. But at the core of it, it's about a shared experience.
And can you talk a little bit about your idea of organized prediction in composition or in music, and how that contributes to the success of a composition, maybe?
Yeah, absolutely. So when we're talking about listening to music, right, we are using knowledge that we have in our brains of what music should sound like when we come to interpret the musical sounds. So a big part of that is about being able to tell what's about to come next. So for example, if you're hearing a piece of music in C major, you expect it to end in C major. And then on a moment by moment basis, you're forming certain expectations for, well, you think it's going to be a C, or you think it's going to be a large interval, or you think it's going to have this 4/4 rhythm. You might not explicitly know what to call these things, but you still implicitly have some knowledge of that structure of music and what it should sound like. So even people with zero formal musical training, when they hear a note that doesn't fit within a scale, or a sour chord within a piece, they might still know that sounds wrong. So I think that's mostly what we mean when we talk about predictions, right? This knowledge of what's about to come next based on what you already know about music that you've encountered in the past. And I think that the organization part of it, again, is very much about the structure of how sounds tend to be, the structure that musical sounds tend to follow, both within our culture and maybe to some extent that reflect physical principles of sounds and vibrations and frequencies, and how they interact with the environment in the world. Yeah, so I think organized predictions is really a way of putting together what our minds are capable of and what the environment is giving us.
Right. Well, so this might be a good place to sort of talk about your work with looking at the brains of musicians and sort of how the brains of, say, jazz improvisers or classical musicians or other types of musicians, how they work differently or how they look differently, and sort of what technology you use to sort of understand those things.
Sure, I've thought a lot about jazz musicians and improvising musicians, and maybe this is partly because I am a classical musician, classically trained musician. I've played piano and violin since I was 5. Um, but I don't really improvise. I mean, as a very kind of thorough classical musician, I play with music in front of me. I could come up with a few notes when there's no music in front of me, but I also just feel quite afraid. So I think at some point in my research, I just wanted to know how it is that jazz musicians can do this beautiful thing that sounds inspired and fresh every time, and it's always so exciting. And so we used a variety of tools in my lab. Some of them are better at looking at where in the brain is active when someone's going through some kind of mental activity, such as jazz improvisation. So those are functional magnetic resonance imaging, or fMRI. We also have tools to look at when exactly the brain activity is happening, like after some musical experience or before some musical experience. So that's event-related potentials, or electroencephalography, or EEG. And so those are brain waves or brain recordings of electrical potentials. And because the electrical potentials are closely tied to brain activity itself, that gives you a really good time-locked response to how the brain responds to music. So what we've done is a few different studies where we compared classically trained non-improvising musicians against people with jazz improvisation training, and then also against people with no particular musical training, who are just young adults who have heard music but don't particularly play themselves. And what we see is that in the EEG studies, within a second of hearing anything that's slightly unexpected, right? So I can give you some chord progressions. Maybe I'll play a chord progression in an example. And what that sounds like is something that's quite normal and expected. I mean, it's a chord progression that you might not have heard, but it follows the structure of a lot of how Western music is written. So it's like saying, I take my coffee with cream and sugar, right? Or I could give you another chord progression that sounds something like this. And that's like saying, I take my coffee with cream and socks, right? So that you don't expect the word socks. There's nothing wrong with the word socks. It's a perfectly fine word. It just doesn't fit given what's come before it. And so what we've done is looked at how jazz trained musicians and classically trained musicians' brains process these different kinds of chords and chord progressions. And what we're seeing is that within 1 second of the unexpected socks progression, so the last chord, we see that jazz musicians' brains are sooner sensitive, more quickly sensitive to the unexpectedness compared to classical musicians or musically untrained people. And then what we're seeing is that everybody's brain notices within about 400 milliseconds. Everybody's brain notices the unexpectedness. But then around 800 milliseconds after the unexpected chord, the jazz musicians have actually gone back to baseline. So the jazz musicians and the non-musicians are both at baseline, whereas the classical musicians' brains are still kind of ruminating and still almost fixated on those unexpected chords. It's as if the classical way of thinking about something unexpected is, well, that's probably wrong. and how can we make that not happen again? Whereas the jazz musician improviser's way of looking at this is, oh, that's interesting. Okay, so now I've learned from that, and I'm going to move on, right? So I think that study, just from looking at these time-sensitive brain measures of electrical potentials on the scalp, you can really get a pretty detailed picture of how different kinds of minds work, and how different kinds of musical training shape you into how you are, and how you interpret your environment. Then we've also looked at different networks of brain regions, and this is using functional magnetic resonance imaging now, and we're specifically looked at what's called resting state functional connectivity magnetic resonance imaging, and what that does is it's essentially a video of all the different voxels of brain areas over time, right? And so when you're recording different brain areas over time, what we're seeing is that there are certain areas of the brain, certain brain regions that tend to be co-active in their activity. And so those areas, we call them functionally connected, right? In that they're part of the same intrinsic network. And what we're seeing is that the jazz-trained musicians have differently connected intrinsic networks compared to the classical musicians and the people with no particular musical training. So especially these areas that are part of the executive control network, or that are important for doing things like planning and math and recognizing structure within sounds, that tends to be more flexibly connected to another set of another network of regions called the default mode network within the jazz trained musicians. And so the default mode network is really interesting because it's been tied to creativity or creative idea incubation. Like if you are stuck on a problem and you really want to sort of step back from that problem and maybe take a long walk or take a long shower or something and let your ideas kind of mull for a while, that usually is tied to this default mode network of brain function. And what we're seeing is that for jazz musicians, that default mode network is more closely coupled to areas that you use for executive function and executive control. So it's a little bit, I think, a more detailed picture of looking at how the mind works when it's trying to be creative in real time, which I think is fundamentally what musical improvisation taps into. What we're seeing is that it's not like you're particularly using one part of the brain or particularly not using one part of the brain. It's more that different areas and networks of the brain are more flexibly integrated or incorporated in order to facilitate that real-time creative experience.
That's really fascinating. That's amazing. And I wonder, like, how does do you have sort of insights into different applications of music memory where if you're a classically trained musician, you may have to memorize pages and pages and pages of music to perform them, and if you're a jazz musician, you have a different sort of thing that you have to memorize, where it's a looser kind of structure, but there are sort of all these underlying principles that you have to apply in sort of real time. And how, what sort of things have you learned about musical memory?
Well, there's a lot there. I mean, so I think that when we're looking at jazz trained musicians and classically trained musicians, I think the underlying frameworks for music, right, and how music is structured and how you learn how music is structured is a little bit different between the different genres. So, for example, for classically trained musicians, the notes are already given, right? So you know which notes you're supposed to play, but then the artistry comes in the articulation and the expression, and and maybe the rubato and all these all these ways you can play with the music. Whereas for jazz trained musician, for improvising jazz music, you don't really know what notes you're going to play, but you have some representation of what sets of notes are usually likely to follow any given sets of notes. But then the decisions you're making are in real time on a moment by moment basis about which note to play, right? So I think the decisions are a little bit different, and therefore I think the memory representation is a little bit different. So I've also spent some time looking at learning and memory in and for musical systems that are neither classical nor jazz, but really a completely new scale. And what that gets at is something that's kind of at the core of the nature nurture debate, I guess, for musical experience. Which is that how do you know what you know about music? And of course, it's easy to say that, well, if you've been steeped in one tradition, then you'll know information from that tradition. But what we don't know is to what extent you're born knowing some information, right? Or you're born with some predisposition to learn certain kinds of information. So I think that for example, with very dissonant chords, right, or very dissonant sounds, it's very hard to think of that as an anchoring point for music. And so I think that the context really matters a lot. But then also, what you're exposed to within a short time matters a lot too. So what my lab has done is come up with a new musical scale or a new musical system in which these consonance and dissonance principles are a little bit different. So I could also provide some examples where there's some I feel like when I listen to this new musical scale, it's called the Pier scale, and it's derived mathematically by Bolin and Pierce independently. And what that music written in this scale feels different, right? It's different from anything you've heard, but it also sounds like it could be very viable. It could be familiar. And I think that's particularly fascinating about it. And what we've seen is that within about 20 minutes of listening to music in this new system, your brain starts to look like it does for Western music, right? So you're essentially assimilating these new statistical properties of sounds as you're being kind of put into that environment, and as you encounter those sounds and those probabilities for the first time. And so what we're also seeing is that within the course of an hour, your brain starts to look more and more like it does for Western music, as you're listening to more and more of this new music. And so I think that's also kind of optimistic for new music, for people who are trying to do something different with sounds and trying to see to what extent we can play with the expectations that are so ingrained. And I think it makes me certainly feel a little bit more open-minded as a musician myself.
Well, that's great. Maybe we could hear a little bit of the Bolin Pierce mode right now?
Yeah.
That's really great, really interesting. I wonder if we could talk a little bit now about something that I feel like I've always been taught in terms of learning music, which is repetition is really the key. But you seem to have found that it's not just repetition, or maybe not as important as variation in learning.
Yeah, what I've seen, and I think this echoes some of the work in language acquisition and language development literature within developmental psychology. I mean, there's of course lots of work, very very important work looking at how babies learn language, and how we can help babies learn language. And it turns out that if much of that information, much of what gets in to the brain is not explicitly taught, right? It's not about having the same thing happen over and over again, but it is about being exposed to many different kinds of sounds or many different kinds of stimuli in the environment. And so that's tapping into this literature that's becoming known as the statistical learning literature where it's quite different from, let's say, explicit instruction, where where you have the teacher teaching certain things by rote repetition. It turns out that much of language acquisition and also music acquisition doesn't work like that. It works more by hearing sounds and hearing the associations between sounds in the environment. So a really classic example is, if you hear if you hear, let's say, again, the C major, a piece in C major, right? You're primed to expect a C, even though nobody told you that it was in C major in the first place. And nobody told you that if you've heard something that's a G chord in the C major, you're supposed to expect the C. You just learn it from being exposed. And what we're seeing from this Boll and Pier scale studies is that people are better at learning new instances of the Boll and Pier's melodies as being familiar to them if they've been exposed to more different melodies within the Boll and Pier scale. So compared to hearing a small number of melodies repeated over and over again, you would learn those few melodies, but then you wouldn't learn any new melodies as being familiar. So that's kind of a rote memory condition. But then the best learning condition is actually a more, not a rote learning condition, but a varied learning condition, where instead of getting 5 melodies 100 times each, you're getting 500 melodies one time each, right? And so that kind of variation is better at, I think, unearthing or helping the brain discover the structure underlying those sounds, and that's what leads to better learning of new items. And I think it's a bit, the way I think about it is, I also teach in the classroom a lot, right? And I think that's, and the way you can tell when someone is really working hard, is really learning something, is not just that if you tell them to do one thing, they do that thing, right? But if you tell them to do one thing, they then generalize and apply the principles that you've talked about to new things. So I think that has some education implications as well.
Cool. Wow, that's really interesting too. I feel like this area that you work in is so vast, and it's really hard to cover, in a brief period of time. But is there anything else that I haven't asked you about, or that you feel is important to sort of include in this little talk?
Well, I do feel like, I think for a musically sophisticated, musically savvy audience, it's nice to think about how music could be a form of brain stimulation, right? I mean, I know we know that different kinds of things in the world are activating our brains all the time, and that's how we're able to function in the daily life. Um, and we also know that music isn't just stimulating one part of your brain; it's stimulating lots and lots of different areas of the brain. So if we know that already, then why can't we actually think about music as a way to stimulate the brain? And if that is the case, then is music composition or music making really an art, or is it also a science, or is it also a way of coming up with new patterns with which to stimulate the brain, with which maybe to help people who maybe have different kinds of disorders, or maybe help people whose brains are growing in the classroom, or people who maybe have neurodegenerative disorders, or who might be losing some kinds of brain functions, later in life. So I think my work is really, I think I think of, kind of existential questions about why music is and where it's coming from, but I also try to apply it to some real world applications to help those with different kinds of disorders. And and with the knowledge that maybe the most appropriate music for stimulating the brain might just not even have been written yet, right? Because I think that the ways, with new kinds of technology, both in understanding how the brain works and in making sounds, I think they're really affording lots of ways to use music to do new kinds of good that we didn't know were possible before. So I tend to be very optimistic when I think about what music could do, for the brain, not what we've already shown, but what we haven't yet shown. But given, as you said, the vast world of of mysteries that's out there, I think that we shouldn't limit ourselves to thinking of music as a set of things that have already been made, and a kind of quirky art form, but really as something that can be used as a scientific tool for understanding the brain and helping people.
Oh, it's really good to hear you say that. I've always sort of felt as a non-scientist that music is definitely as much science as it is art in many ways. Well, I want to thank you, Psyche Loui, for being here. And we really appreciate it. And it's really good to talk to you.
Thank you, Wayne. It's great talking to you too.
Now that we've had a chance to gather some initial materials as starting points for balancing sculptures, we're going to do a deep dive into connector pieces, which allow you to make small adjustments, complexify your sculptures, and really unlock your creativity. We'll be talking about making our own connector pieces using cardboard, which you can see here too. They allow you to slide parts, make slight adjustments, decide where weights should be distributed along your sculpture. And then Ryoko will be joining us too to talk about using buttons as connector pieces.
Here's an up-close look at those cardboard connectors that we've been talking about. And you can see it's just a piece of cardboard that you've cut out and then punched some holes in. You can then stick pencils or other long implements through to connect them and make slightly more complex, elaborate balancing sculptures. The cardboard pieces also can serve as a stopper, so you can make really precise adjustments to what you're working on and distribute weight in specific ways. We love that these cardboard connectors are so easy to make, and they allow for more complex and interesting builds as you explore balance.
Cardboard connectors are just one way to go deeper in your explorations of balance. My teammate Ryoko has been playfully using buttons as a similar type of connector piece.
Here's a peek at some of the colorful and joyful balancing sculptures that she's been building. Ryoko, I'll pass it to you to say more.
Hello, I'm Ryoko from the Tinkering Studio. So one of my favorite materials when making balancing toys is this buttons. And buttons are great. They already have these holes. So they are actually easy to add or subtract from your sculpture. One of my example is this one. This one I used wire and Play-Doh as a weight. And then I can add as many as buttons I want. In this case, I'm just using 3 buttons. And sometimes the hole size and your wire size, they don't match. But in this case, I just wrapped around some masking tape so it can fit. And I can shape the wire in any way I want. And it's amazing. Just a little bending affects how your sculpture behaves. Oops, so I messed up something. Bend it back. Yeah. You can also use something like toothpicks. Toothpicks are really good with buttons because it's good size. Then you can add, because it already has holes, add more like this. Yeah, they're already making a good balance. You can of course add something like other objects, clothespins, and make your sculpture more interesting. Oops. Whoa. Oops. I need to work more. But yeah, buttons are really great materials.
Now that you've seen some ideas for materials, bases, and connector pieces, here are some cool projects that other makers and tinkerers have been trying out.
This is Sebastian, also from the Tinkering Studio. He's been building little balancing sculptures, or balancing toys like this mosquito. You can see the toothpicks that are coming off the sides. It's balancing on a pin, and it's got a cork body. Plus, googly eyes for some personality. Another take on the balancing toy is a riff on the classic balancing bird. This one's made out of cardstock, and then different materials are being attached to the wings as weights. So you can see clothespins and even feathers change how it balances. Cats can explore balance too. If you need some inspiration, you might consider trying to make a balancing toy for your furry friends. Here's an example of using potatoes as a fun and unexpected connector, or raiding your kitchen for utensils to test out. You might take your balance explorations outside and try balancing branches or other natural materials. There's no age limit for balance exploration, so try building with the whole family. If you want to join in on the balance explorations, you can use the hashtag #ExploringBalance to share your ideas. Thanks for building with us after dark.
Hello, I'm Wayne Grimm here at the CANBAR Forum at the Exploratorium in San Francisco. I'd like to introduce you to Adria Ott, multi-instrumentalist, composer, and improviser. We're very excited to have Adria here on Resonance Online, and we hope that sometime in the not-too-distant future, you all can come back and see live music here at the CANBAR Forum at the Exploratorium. Please welcome Adria Ott.